Bootcamp. Let, let me take a moment to appreciate you all that you have joined these 2 days continuously. Your dedication and enthusiasm have made this bootcamp truly exceptional. Were filled with incredible learning and interaction, and we couldn't be more proud of the progress you have made. Thank you for bringing us your best energy, and special thanks to your sir for guiding us and expertise and the passion. So over to you, sir.
Yeah, thank you, Kritika, and happy Diwali to all. So, welcome to our final day of this session, like the first boot camp that we are doing. Okay, so as we have previously discussed, today I will be going to discuss about the communication protocols and the different things that you can do with this. And before that, I just want to add on like the practices that we used while developing the code because um, you will see these tutorials that are coming up, right? Like for using and interacting with the devices, you will see tutorials like each tutorial will have one aspect of the thing and you will try to implement it there. But the main problem comes when you try to apply all the concepts that you learn together, right? So how do you manage the code base? So managing the code base in a cleaner way is also an important skill to have for an embedded programmer or any programmer, right? So that's why I'll just give a few discussion about and the libraries, how we can create libraries for Arduino and stuff, and how a library will look like and things like that. And then we'll discuss about interrupts, and then we'll go into the communication protocols. And I do have a physical board with me today. If time permits, I'll also try to do some of the things in the physical board. Okay, let's start. Okay. So today the first thing that we are going to see is about classes and libraries. Like it's a continuation of what we did yesterday. I'll just copy it up. I hope my entire screen is visible. Is my entire screen is visible?
Yes, sir. Is it visible?
Oh, sure. Okay. So the idea is yesterday I think we created a struct called blinking LED, and then we used a blink function to update the blinking uh, in a loop, right? So what we did is since this is a CPP, which is C++, I went ahead and created a class out of it. It may feel some similar. You can see the similarities between the class and the struct. How we have defined the values in a struct, and these are the parameters or arguments or class variables, as people call it in C++. And you have this init function. Uh, so why this is init is there? I think yesterday we just put all these things inside the setup function. So what I created it, since we have put everything inside into this blinking LED class, I took the init function that will do the initialization for us. So for each blinking LED, it will do the initialization, set up everything. We set these things, so we don't have to worry about how that is implemented. And one more thing you can notice is that I have used this comments. So how does that comments help? So if you use any standard editor nowadays, these comments will pop up when you hover over this as a help text. So since I am moving this, so as you can see, I am moving the code from, so this blinking LED is not defined over here, but I created a library in this lib folder with the name super LED, which helps us some utility classes, it provides some utility classes for us to work with LEDs. And I created a super LED.cpp and a header file. So in this header file, it's just, so I think I used, yeah, we should do something like this. So which means this defines, if it is not def, we have to define it. And so this is a standard header file. So what does this mean? Which means if we haven't included the super LED yet, then include the C++ file. Otherwise, don't include. So the first time it is doing it, it will define this. So it won't include this multiple times. So this is a standard header file that people use for including just a library. And we have the CPP file here, which has this thing, right? And now we have these three functions, which init, which sets the pin mode, and the pins, these variables with the pin and the blink delay, and the blink function, which will do the non-blocking delay. And I also went ahead and thought of a case where if we want to blink a LED in the setup function, there won't be any loop going on. So this blink function won't be useful there, right? So we need a blocking blink function, which uses the this thing. And I also added a parameter here, n blinks, which means we can like if you just call blocking blink, it will blink once, and if you put any number of times, it will blink n number of times with this blocking delay. So I went ahead and created a CPP class. So if you know C and structs very well, learning classes is not a very difficult thing. This can be super useful when you are doing hybrid development, like organizing each component into separate libraries. I hope you will also be using library most of the time while you are using Arduino, but that will be the already available libraries. Basically, a library is just this kind of CPP files that you have. And what they like this Arduino IDE provides a GUI way to put that in here. So that's the idea. You can also create your own libraries like this. And I also created another class called binary LED array, which means assume you have n LEDs and you can represent that n LED as each bits, and this will the set value function takes a number, and what we are doing, we are converting that to binary, a number to binary. So assume you have 10 LEDs, so that's what we are going to have, and the 10 LEDs in each LED will be considered as a bit, and we can set different configurations of that using this set value function. So for example, so I'll actually demonstrate this and how we can use this thing, and then we'll come back to the code and revisit this again. Okay. So as you have seen, I have already set up the project here. This is Arduino, and the diagram.json, which is the one that we used actually yesterday, the LED bar graph, and have the main CPP here. So let me comment out first. We'll go with the blinking LEDs. So you can see I have included our library that is present here. In here. So I'll just comment out the things that we don't need. First, I'll. So this is about the blinking LED functions. Oops. Don't worry about this now. Now so now you get the idea. So what I'm doing is I'm initializing 12 blinking LEDs and a single blink LED. So this is to demonstrate non-blocking blink. So what's the code says? We are setting up the inbuilt built-in LED to blink 5 times, right? So we are initializing the LED built-in. So what it will do? Configure. So do you know why the dark stream is important in the library? Because libraries, we usually don't see what is there. You only be coding here, right? But you need to know what that component will do. So it's a kind of quick look. You want to know, right, what that will do. And I have also added a sample program using which you can do things. Kind of that. And now let's see the code one by one. So this thing set up the LED, and this makes it blink 5 times with the interval delay of 200 ms. And when we are initializing, uh, let me do this thing. Start simulator. Okay, oops, I have to compile this. So what I'll do is platform IO. So if you install the extension, you also have these things, build and upload buttons for platform IO thing is there. You can also run that, but I prefer this command line. So I do this. Now we have built it, and we'll start simulating. So we have the simulation here. So let me explain how the simulation works. I hope the contents are visible. Uh, like Zoom is fine. So let me restart. So this is the reset button. If you have read this, the program will start from the beginning. You see, this is the built-in LED. So if I start, it will blink 5 times, and the program goes on. You saw this same output, like we are blinking different LEDs in different delays. That's the same thing. But the one thing is, we have a init function now to set up the pin and the blink LED delay, and we have the blink function to be used in the main loop. And this blink function is also there, which blinks the this LED that we have defined. So that's why you can see the inbuilt LED is also blinking, right? Okay. So now this is one case. So is there any doubt, and are you able to understand how this library and things work? And you have this README, good README provided by Platform IO that actually helps us organize. How do we organize the library? We can provide examples under example folder. So if you see, I have just put it here, but you can also put, like, this is one way of doing thing. So I followed this one, and you can also have a library that has a structure like this: a docs, examples, source code, and these examples can contain what I have put in there. So uh, in Arduino, you can find these examples coming over here in this example section. So if you like have examples with Arduino, okay, in the project, you can see this in examples. All the for all the libraries that you install, you can see the examples here. So that will be coming here, the examples. So that's why this thing is there. Okay. Actually, when you add a library, Arduino actually links this library with where it is stored within the inside this Arduino. It hides all of this abstraction, but when you are using Platform IO, you can clearly see what are the things that you need, what are the things that you have, and how you can organize code. Okay, uh, and I think I'm going super fast. You can slow me down if you want. If anyone have any doubt till now, okay. So that's the first thing. And now let's start with the second one, the LED array thing that we did. So now let's focus on these two things. So the idea is I have this 10 pins, this pins. I have set it up as LED pins. So the binary LED actually requires two things as a input: a LED pins array and a number of pins. So since uses C and C++ use pointers for array, we need to know what is the upper limit, how many number of elements that we have. So that's why this 10 is here. And during this init, what happens? Let's go to the super LED CDP. During the init, we'll just initialize all the pins to output that are present here. Right? That's the common thing that we do, right? And in the cell loop, I'm setting LED array value to some binary value. So what is basically this code? I'm taking a number n, and I am getting the remainder by 2 every time, and then dividing it by 2. So can you remember this pattern? So how do you convert a number to binary usually? You start with the number 45, then you divide by 2, right? Which is 24, and the remainder will be 1. So this will become the last bit, right? The least significant bit. So that's what this is. The remainder when divided by 2. And then n will become n by 2. Then you again divide it like that, right? It will become 12. And the remainder will be 0. and that would be the second least significant bit. So that's what this code here is doing. Basically, it's converting integer to binary. It's collecting the bits, and we are setting that bits a 0 or 1 to the ith pin. Okay, so you may see that it is going in a reverse order. Like the 0 indicates the least significant bit. The position 0 indicates the least significant bit, and this position n signifies the most significant bit. So that you can see, understand, right? So now let's uh, what we'll do. Okay, yeah. Now let's see. Uh, I'm just going to give a simple demo first. LED array dot set value of 1. Okay. This thing. So whatever comments that you write before a function will be displayed when you hover over it. So that's why it is taking that as comments for that. Okay. Set value 1, and I'll use a simple delay of 100 ms, and I'll set this value to 2, and I'll set this value to 3, and 4. Now let's compile and run this. You see this? It's going from 1, 2, 3, 4. Maybe I'll increase the delay first so that you can easily see the difference. 1, 2. Oops. Oh, I haven't used 3. Okay. So 2, 4. You have to see from this. This is 1, and this is 2, and then 3, then 4. You see? 2, 3, and 4. How it goes. It's basically setting that value. So using that, since it is using that binary logic, we can do something fun like this. Assume this is a binary 1, right? And if you remember this is a shift operator, which is a left shift operator, which means once you shift a bit, so initially it will be as 1, and then it will go to the second bit, which is then it will become 2, then it will become 4, then it will become 8. That bit will shift to one position. So what will happen? Let's see. You are shifting that value to there, and then in the next loop it goes like that. And what if you have 3, which is 1 1 in binary, right? And you can have all the ones that you want. And you can also have zeros in between. It's fun, right? Like how we can build a library ourselves. And actually, you can import this library into Arduino by just zipping this. You have to just zip this folder, and then you can use import library function tools. I think this one, include library, add zip library. You can just put that here. Actually, if you see, I think I have added that super LED here. So I have already added the super LED thing here. So I can use super LED in my projects in Arduino IDE also. So that's how you distribute an library. If you also see the libraries, uh, they are all hosted in GitHub basically, and there will be you can add that using this here. So now we are not going to worry about the Arduino library thing. I'm using this platform IO and VS Code to give you uh, a sense of how things can go. Right? So like we can look under everything. in detail rather than hiding away from the abstraction that is caused by this Arduino IDE. We can do these things. Okay, so anything you want to ask till now? That's good, right? Okay. So now, so far we have used this Arduino board, right? What if we want to use the STM boards? One thing is that in what we have this STM board C031C6. Actually, I found out that in Platform IO they didn't provide this board for us to work with. So, but they provided a way in which we can add to this one. Uh, this one. So this is how Platform IO is managing the boards. So they use a JSON which has all the configurations about the board. And what I did is this. So if you go to home, there is they have said this thing, which is we have to put this file inside a folder called boards in the boards directory, which is present in the core directory. And the core directory is dot platform IO, home platform IO in Linux systems. And this is the path that is present in the Windows. So in my system, I am going to find this directory, which is hidden and present here, which has this platforms, STM32 boards, and you can see all the boards here. You can see all these Nucleo boards, but this file here I have created based on a similar board. So I saw what are the parameters that they have given for this board, and I changed these values accordingly to create a configuration for the board that we have. So it supports most of the boards, but we actually don't have these things, right? This board they don't provide it, right? But I can actually create a file like this. Basically, looking at that and changing the values according to this board. Okay. Now what I did is added that file to this boards. So that's how they described you can add a new custom board. So I followed basically these things and created a board for us. So usually, if you run this command, uh, platform IO boards Nucleo, you won't see this board, which is the board that is present in WordP. But I have added, since I have added this, you can see it coming in the boards list. So I have added this thing. Okay. So now we can program with this board. Okay. So let me open up a project where we'll do something with that. Okay. Let me start a blinking LED thing. Right. We'll have LED over here, ground, and we'll see how we can quickly do this. E, nice. Yeah. So I have created the project and configured it already so that we can quickly go. And in the platform.ini, you can see that I use the platform, this one. You can actually, since I have added the JSON file, you can quickly create this. If you don't have this platform.ini, what I can do, I can initialize that, right? Platform, I know project, init, board, and this is the board that we have, right? Nucleo C0, P1, C6, and the project will be updated since I have added that JSON file over there. So if you want the JSON file, I can probably share it. So do we have any folder that we are sharing contents or something like that? Akhilesh or anyone? Maybe I'll put that things in GitHub and maybe share a link there. Okay.
Okay, sir.
Okay. And you can mail them later. Okay. Okay. So now we have initialized this project for our board, which is this. Now we need a walkp.qml. So before that, and we also need a diagram.json, right? For walkp. So we'll copy the diagram.json from here. We have to edit it with text editor since editing the diagram editor is paid in offline edition. We can always do this. And src, we'll get the main.cpp and include Arduino. So usually in Arduino IDE, this Arduino.h will be by default included. So that's why you don't have to write these things. But, to the- so let's keep this for now. Let's add the diagram. So let's first do uh, run so that we generate a basic build file. So it is taking in the libraries from there and actually some warnings it builds. So it's putting the firmware in firmware.bin and the elf file over here. You can see the build directory for this board. We have a bin and elf. That will add to the walkv.qml. So this is the format for walkv.qml. One firmware equal to this one. And this what is another field that is needed. You check the other projects. Elf, elf. So now we have set up the 2ML configuration. So now we can start the simulation. Now we got this. Now you can want the core LED plate. So we have connected this to 13. This 13. So I am using 13. So if you see this STM board is actually Arduino compatible. These pins, you see these pins are Arduino compatible pins, and these are additional pins with some more additional functionalities. Okay, but these pins are compatible with Arduino, so that we can also code the Arduino code in this. Pin node, LED pin, out. You can just copy the blinking. You can use Super LED here. Super LED, blinking LED, photo, like initialize LED dot init, then is 13, and blinking delay is 1000 ms, and we'll blink it. Okay, we'll compile this. Now we can see daily deployment. Right. Does this look cool? Uh, how with platform IO we can actually have a setup for our project. And one more thing is, since we have this in local, you can always version control these. If you want to use Git, you can do that. You can add a Git ignore file to ignore these build directories, and you can easily share that project to anyone. All the configurations and setups are done here. Anyone can easily reproduce this project, right? Uh, so any doubts till now? And now we'll see how we can actually uh, code in this. Uh, we'll see the communication protocols. So first, one of the basic communication protocol that we usually use is the serial. So just to send data, two-way communication. So there are these TX and RX pins which are used in the serial communication, and also you can see there will be some uh, yeah, and these pins SEL and SDA are used in uh, I2C communication, and you can see this MISO, MOSI, SC, these pins and SCK. These pins are used for SPI communication. So in here, the MOSI means master out, slave in. So they used these terms, but then later in some libraries they started to find these terms offensive and they changed it to uh, I hope it is COPI something like that. It's somewhere around like that. So you can also find this other uh, way that's there. So here we have certain projects that we have done as a part of this, which will actually help us see these things. So this is accessing this uh, temperature sensor, but we actually don't have this temperature sensor in Workday. Maybe we can define that using that chips API that I have told, but now we don't have that. So for now, the other sensor that we have with Workday is this MPU 6050. It's a gyroscope sensor. So that this lab manual is written for a different variant of the Nucleo board, which is Nucleo 144 F7 is the type. But the board we have is a different. So we can see how we can adapt this to that. So usually we are using this library uh, NPF 6050 that has all the things that is initialized. But you will get. I'll also show how we can manually access the registers in this temperature measurement, which I will do using a physical board that I have now. Okay, so before that, I will show how you can do this with this library, and we also see how we can import that library into our platform, our IO project, and quickly use this. Okay, so let me create a new project for that. Okay, uh, yeah, so cool. Uh, Maybe we'll first copy this. So I may not be going in a right order, but I hope to cover as much as I can cover. So bear with me. If you want to interrupt me, you can always interrupt. Okay. So we go here and start on this. So we'll create the diagram first. So this is using I2C, right? So we need this MP, oops, need this MPA. This is the accelerometer and gyroscope. It also has a temperature sensor built in with it. I don't think we are going to be using that. Let's see this. Uh, this is, can rotate this. Okay, it's not like- now this looks good. Okay, and now, so if you closely see this thing, so actually this NPU have SEL, SDA, and this is for VCC and ground, and also it has XDA and XCL, which is for which is like you can actually send this data to another code also, kind of that. So we will be only using these four pins for our now. Just we are going to connect these things SDA and SCL and VCC ground. Okay. So SDA is for data and this is for clock signal, which are the two pins that are needed for I2C communication. So this is an I2C based sensor. Like that, and we need voltage and stuff. S- Now, so now we have all things set up. So, JSON. Oops, text editor. That. Now we'll start this. So you can see that first time when it does this, it takes more time, but when you do the second time, it actually reuses most of the code. That's why it is like most of the compiled intermediate compiled things that it will reuse. So that's why it is taking this time and do it second time. Okay, so we'll start with CPP, start simulator. Is that actually this code for that laboratory is done using this thing a library, which is actually we are actually using a library called MPU, and that library can be found using. So this is a library by this guy, electronic cats. You can find that in Arduino IDE, and also you can find the file here. And this is what we want basically, right? You can download that as a zip and copy paste it there, or you can use git clone to do that. Since I am using this Linux system and I have git, I do this. I'm going inside the library. And I am downloading that library. So see how command line works. You don't have to go to library manager and download. You can just search any library from the web and just pull it down here, so that we get access to the other libraries that are not present in the Arduino library manager also. Okay, now we have this library, and we have to just, this is most of the thing is just uh, copy paste stuff here because it's a library code. I just followed the one of the examples that they are given and modified it a little bit. So we'll use that .cpp with Arduino. Let's see. So this, you see, I am using serial here, which is the UART, and I'm going to print that, like, when you actually connect a development board to your system, the debugging information can be retrieved from the board through the serial. So the serial data, the UART data, can be also transferred using this development USB that you will be connecting it to the. So you can actually see that data from this board coming to your system, and you can visualize that. But this simulator will be doing that for us now. So what I'm going to do is, I'll come back to my home. Here, I'm going to compile it again. See, it's using that library, compiling all the things. Okay, 10 seconds. And now we'll see here. You can see the values that are printed over here. So now I'll change the values. Now does it change? Okay. Just verify the connection as well. CL, CL, okay, let's check this I2C address there. JSON. Okay, this one. So each device will have its address, right? So I'm not sure. Maybe the address of this may be different. Here we see what is the default address. So this address there is 6. Okay, this is our things. Voltage supply 6.9. So is that what we are using? So 6.8 is given. Okay, okay, it is 6.8 only, right? I have to say address is 6.8. Okay, so okay, so when we have that, they're using this Adafruit library to do this thing. Okay. check this once. Okay, first we'll check whether that is supported in this STM board. Okay, that might be the case. I haven't checked that yet. Let us see this master mode only. Okay, this we are in the master mode now. We go. Connection failed. Okay, it's saying connection failed. Okay, now let's try connecting this to instead of 3 with 3, let's try connecting to 5 voltage. This connection is failing. I'm not sure. Not sure why it is not working before. Maybe let's try this with. Otherwise, let's try the Adafruit core there. Try this one here. So I think for that we would have to download these two libraries also. Okay, let's try that. Sure, why this is happening. This. Let's try this once again. Using everything, compiling it. Let's see whether this is working. Failed. It's failing now here. That will check later. Okay, just a couple of seconds. Maybe I'll try that with the uh, offline board that I have. Just a few minutes. Maybe let's reset this. Look at what we just verify that it is possible to connect it. connect my device over there. So I have connected it. So I'll also set up that for that our code, which is 274RE. Okay, so we have set up that one. Okay, maybe we'll try this with the actual code, because we have tested this code in the other code, so I'm not sure since what is not supported or not. Watch it. So we are going to run this G4 and going to upload it. See, it's compiling all the libraries. Started. Now let's see this indicator. The moderators actually they set it to printing values. Okay. It seems it's not working properly. Here, slow down the. Loose connection. Oh, what? Let's try. Successful, right? Yeah. So there was a loose connection in the connection. That's why the values are not coming. Yeah. This code, as you can see, is actually working. So now let's remove this delay. So I actually picked this code from the examples that they have given for this library. But why I chose this library instead of the Raft library is that because you can actually see the code there, how they are developing the I2C. But this is quite complicated. That's why uh, I didn't see this. But with the next exercise, I'll be using the temperature sensor to do things. There you can actually see the code and how that I2C is happening. For now, basically we are connecting that, and this get 6 motion is doing this. Not sure why it is not working with Rockly. Uh, the same connections and not sure. Let's try once again Rockly. Maybe that protocol is not properly supported over there. It's built for things. It's within connection failed. I'm not sure, maybe in Walkly it is not properly working. But actually, this is the exact same connections that I'm having in my local board. It's a different type than that 1% in working. Maybe we'll try using the Adafruit library and let's see how that works. So that's how we can try, right? Okay. So, yeah. Adafruit sensors. So Adafruit is a sensor manufacturing company. So that's why they have their uh, libraries built for most of the things. Not only sensor, all the peripherals they built. So using that now. In Arduino, they are given these pins there, so you can also find that in Arduino. Not sure about this one. Let's try this. There you Arduino. It's really nice. It's not. I think it's not supported by this other code. So I think it's failing. Uh, should be like this because we have that. Okay, I think they have this dependencies coming on the. I think we can add that. Add it here. So I think we have to add those dependencies for that. It actually needs this one. Let's see whether that library is available in platform I was registry. If it is, I think it's there. Let's search here. The sir, I think then we have to manage these things. Okay. Oops. Maybe one thing, it's taking time, so we'll not go forward with this. So you know how that works. It's working with the real code. Maybe it's the problem with this working simulator, so that I'm not sure how it is working in there. Maybe with the code it is supported. In STM32 code it is not properly working with this sensor. Maybe you can try with the board example. For now, this is fine. So actually, now I'll show you how the temperature sensor work, where we can actually see the code that is doing the I2C communication. So this is the sensor that I have in my actual code. I'm going to connect this. Just a minute. This works now. Okay. So now I have connected these things. So this is the library that I am actually using, seed MP MCP9, this library. So this is actually found in here. So this is this group temperature sensor that I am using. So I'm using that library here. Okay. So now let's demonstrate this code of how that works, and maybe I'll put this library, and then we look into doing the same thing without this library. Okay, so let's try if this sensors and stuffs are working properly. Okay, so I was here. Now let's here. Uh, do something. Sensor failed. Another loose connection problem issues. Just a minute. So they have this working on.
Hello, sir.
Yeah, I think it is not working. There's an issue with the
Yes,
sensor.
sir.
Okay, yeah, it's working now. Okay, fine. Okay, now we got the readings, right?
So, what was the issue, sir, actually?
The connection was not perfectly there.
Oh, okay, okay, okay.
And now we have the readings coming. Now let's me heat this up.
Okay.
Okay, again it got stuck. Oops. Oops. What's happening?
It's again like that. Yeah.
Now it's fine.
Right.
There was a loose connection.
Okay, okay. So,
And you can see the temperature
yeah,
is
it's
increasing.
increasing, right?
Yeah. So
So, you are using your hand or something, right?
yeah, I am uh,
Yeah, yeah,
rubbing
that
my
shows.
rubbing my hands,
That's
and
fine.
yeah, yeah. That's why you can see the temperature is rising.
Yeah, it's increasing. 35, right?
Yeah. Okay. So now let's look into this library, how they have designed. Actually, if you look into this library, this Seed Studio library, it is actually quite clear, easy to understand. If you see, they have written it using the this library. If you see this one, they are using this I to C. I to C is IIC. They are giving an address and setting the values. First, we have to set the configuration. Like so, there are some values that you need to set for the sensors to run. If you see this configuration things in this data sheet of the sensor, there will be different. Oops. So there are you can set the accuracy and things like uh, what is the range. So you can configure using certain pins, and You can also do this thing. Yeah, this is the uh, conversion rate and things. Minimum and maximum temperature you can set. So you can set up things like this, and that's the idea. So I have actually implemented this. So they are rating this using some I2C write byte, and those functions are actually they have defined it over here. I think yeah, they have defined that thing using the wire library. So the wire library is the Arduino library that actually provides API for doing this I2C communication. So you see this one to write a byte. So they are creating a function. What it does for a particular address, we have to begin transmission, then write the data, and then end the transmission. So for this address, this value will be written, and like reading these things. So this is writing a byte, and so this is a register value, right? So we can so there are multiple registers in this peripheral. So this is the address of that peripheral, and there are multiple registers in this peripheral, and that peripheral of the particular register we are writing this value. So this is one operation. So they have encapsulated it into a function called this. And similarly, this is 16-bit, which means 2 bytes, right? So for some commands, we have to write 2 bytes value. That's why this they have created this function where they are writing this. So they are shifting the first 8 bits to the side and then adding these bits that side. So you can see that getting combined. Okay. Yeah. Uh, someone listen. Okay. So in I2C, I think you know that we have this two wires, one for clock and one for data, which is SDA and SCL, and it's an address-based communication. So in this through this data, we will be sending this values. So that's what this write does, and this request from will be reading that. So we request a particular address and a particular uh, byte, and it is giving us that value. If that is available, is ready to transfer that value, we'll be reading that. So they are putting all these together and doing this. So this is a big library for doing this stuff, right? They have written this library on top of the wire library that Arduino provides. So you can actually learn things by looking at other people's source code. This is one thing, right? Based on this, actually, I have created another version of the same code that would be pretty straightforward to understand. Okay, this is the now I'll say how actually everything works. Let's compile it. Oops. Uh, what did I Arduino.h. So, uh, .h. Okay. So, I think these functions that we are defined here, I think it should be defined about the setup and so I think fine with the Arduino IDE. So maybe here. Oh, fine. Yeah, we have uploaded the thing. So it's yeah, yeah, Akhilesh.
Sir, actually, as you have written the code in C++,
Yeah,
and you are writing in Arduino IDE, right?
this is VS Code, not Arduino IDE.
Means the code you are written in that form only, right?
So the previous code. So the code
Yeah,
from in this one was intended for the Arduino IDE.
yeah. That's what I'm asking. If
Uh,
you use any other like language like Python and all, then also we can use this Arduino code.
No, 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 no. You have certain libraries built for that. So in Python, you have libraries written in Python, not in C, right?
So CPP, C++ command can be written. Uh,
You
so
can.
this is a type of
Okay.
C++ command, right?
Yeah, yeah. So Arduino uses C++.
Okay,
Okay. So Arduino code is actually C++ code that gets like translated to actual main loop kind of function.
okay,
But if you are using other frameworks like MicroPython and stuff, you have to write libraries on top of that.
okay.
Okay.
So
Yeah.
the code will be completely different what we write in C++, right?
Yeah.
What we use to.
Yeah,
Okay,
they
okay,
have this wire library is the Arduino library that they have built for that Arduino framework. That won't be available in that. But there might be some implementations of the wire library in Python that you can
okay.
find.
Got it.
Some
Okay, sir.
people may have like this idea of this wire library. Why not we implement these functions that are available in Python? So people might have done that. You can search for it.
Okay, sir. Sure. I will ask.
Yeah. Now the code is working. Let's see the monitor. Yeah, you can see the values coming here with this. But if you take a look at this code, it is very actually easy to understand this code rather than the that actual code. So you see this init function, we are beginning the transmission for this I to C address. So this is the I to C address for this pin. Yeah, all these addresses I have took from the data sheet. And there are three registers. This ambient temperature register is from where we'll be reading the temperature value. And this resolution register is used to set the temperature resolution. Temperature resolution means, uh, so for example, the minimum change that it can detect. So that is what resolution is, right? So if it can only detect changes of 1 degree Celsius, it is resolution is low. If it can detect changes of 0.01 degree Celsius, the resolution is high. Uh, are you able to get the idea of the resolution?
Yes, sir.
And this is the highest resolution that it has, 625.
So, as you are using as a address as a highest resolution, right?
So
Or
no,
you
no.
are storing it in the
Okay,
address?
okay. Let me show these things. I have actually took these things from the data sheet. So
Okay.
if you go to the data sheet, so you can actually see the addresses of different registers. Let me take you there. Yeah, yeah, this one. You see this one?
Yes, sir.
This is uh, the register for this temperature, the ambient temperature that we have, which is 0101, which is 5, right?
Okay.
0x5. I'm
Right.
putting in hexadecimal. And this is the resolution register, and its value is 8,
So,
right?
yeah.
That's what this is.
Okay.
And for the resolution register, I think the different values. So this is a register, which means it can hold like some values, right? Some
Mm.
8 bits of 8 bits. So that in that 8 bits, what are the values, possible values that we can set there? So that is the resolution. So this is configuration register. For this configuration register, what are the different values that you can set? The upper bound, the lower bound, things like that. And so okay,
Okay.
let me take you to. So let me search it. Just, yeah, the resolution register is here. can see this, right? So in this resolution register, which is has the value of 8, which is what we use there, and the values of possible values for the resolution bits is this. So if you set it to 0, it can the resolution will become zero point 0.5. It can only detect changes between zero point 0.5. We set the resolution to 0 for this bit. The in the resolution register, if you set the value
Point.
to 1, the resolution will become this.
Okay.
So there is a trade-off between the resolution and time taken to compute one reading. So that's what they have given here. If you use the resolution as 0.5, it will take 30 milliseconds to read that value. But if you increase the resolution, it will take more time to read the value. So that is one trade-off that they have given in this sensor.
Okay. So we have to set the implement the value that suitable for our
For our
program.
application.
Yeah,
Yeah.
right.
So here I have just put it there. If you want to take it from there. So all these values were taken from
Data sheet.
datasheet. Yeah. And this we know how the wire library, how do we read and write, and we have to write this. So for initializing, we have to set the value for the resolution register, right? So what is the address of our peripheral, the register that we want to write, and the value we want to write.
Okay.
Then we are ready. So this is the first only configuration that we are doing. We are not so that library support all the possible configurations that you can do using that. But since this is a simple demo, I just wanted to demonstrate simple things.
Yeah.
So we are just initializing the resolution over there and reading the temperature. So for reading the temperature, we have to begin transmission for that address. So in this wire library, as you can see, only two wires are there. At one time, you can only like begin and end transmission. Within that, we can only communicate with one device. But you can actually connect multiple devices in the same line, and with this address, you can change the device that you are communicating with. So that's the advantage of this I2C protocol. In serial, you don't have this address thing, right? So only it can connect between two devices. You can
Okay.
use a multiplexer to maybe change the output that it goes, but that's different thing. But here you can actually use an address-based communication protocol, right?
Right.
And here you have we are writing the temperature sensors value. So we are requesting this. Basically, I am requesting that value. Like I'm writing what value I want. Like I want the value from this register, and I'm requesting 2 bytes, which has the temperature value. And then while that is available, if it's not available, I am out, going out. If it's available, I am reading 2 bytes, the most significant bit and the least significant bit. And I am doing some bit arithmetic. If you see, so I receive 2 bytes, which I have stored in uint 8. Uint 8 is just byte. Uint 16 it 2 bytes, 16-bit thing. So you also see some of those code that are written for there, right? We saw that, right? This these things, read 8 byte and these things. So basically, I am actually taking these things, how they have implemented. I am also actually implementing only those things that we need. So here, I'm reading two values and saving it there. And how I am actually getting the raw temperature. This MS byte, I have to shift it to 8 positions. So now these 8 bits are in that value. I have to shift it there in a 16-bit integer, and then OR it with LSB. So if you do OR, what happens? If it is 1, it will be 1. If either of the 1 is 1, it will be 1, right? So we'll basically we are merging. So the idea is, assume you have the MSB is something like this. I'm just using 4 bits for now. Okay, and I'm going to move this to 4 positions. So I'll move this to 4 positions. Okay, and my LSB this that will have actually 4 values, right? Something like this. And if I do an OR between that, I'll merge these things with these things. So I'll get the whole 8 bytes, like 16 bytes or no. So in this example, I'm using just 8 bytes. That's the idea. You will get 16 bytes uh, by combining this. So now here we get 8 bytes. In the actual setup, we'll get 16 bytes. So it takes in that value. And then what is this? Sign bit. So sometimes the temperature, like since we are doing this stuff, it will give values.
So it
The
is input we are getting, right?
Yeah, this is the actual input we are getting. But sometimes the uh, that bit may be we don't know. Sometimes the value may be there. It's because it's quite undefined, that value is,
Okay,
because temperature will be positive.
right.
So let's see this one. The temperature sensor. Temperature is the most frequently occurring word in this argument. Functional solution timing. So, yeah. So here, if you see, this is our register, the ambit. This is what we are reading, right?
Right.
Okay. So, um, okay, this is, yeah. So this is the 16 bytes that we have actually.
So, can you tell me what is the full form of POR? It is written in the box legend, right? I'm forgetting the
What?
full form of uh, value at POR. Minus n is equals to value at POR. There.
So, where? This
The
one.
bottom box. No, no. Yeah. Yes.
Here, yeah,
In
POR.
left bottom.
Value at POR.
POR. Actually, I'm not sure what it is. I'm actually not sure about that.
Okay, no problem, sir.
Okay. So this is that bits that we are reading actually. This is the LSB and there is MSB. These two things that we are reading. Okay. So you can see this each value here represents some 2 to the power of the Celsius. Right. That's why we are reading this.
Okay, sir.
And so in this temperature, we are multiplying it with this one, the highest resolution that we have.
Yeah.
And then if the sign bit is set, so the sign bit here is uh, 0, 1, 2, 3, 7, 8, 9, 10, 11, 12, right?
Okay.
This is okay, what's the sign bit is
10.
10. Okay, 7, 8, 9. Okay, this is 8, 9, 10, 11. Okay,
Uh,
that's okay. This is hexadecimal, right? Hexadecimal
yeah,
10
yeah,
means
right.
16.
Yes, 6. Yeah.
It's
Yes, sir.
16, right? So yeah, this is 8, uh, 0, and 7, 8, 9. Okay, okay, just a minute. Uh, Sign bit. Okay, this is only of the MSB. Okay, MSB and 0x10. Let me put that in binary. 0b. So in binary, what is the value of 10? So 10 would be.
It's a
So
hexadecimal.
okay. In 16, right? In
Yeah.
16, what is the value of 16 would be? It's 0 and
In
0,
binary.
1, 2, 4, 8. 16,
Yeah.
right?
Right.
So this is
Yes, sir.
hexadecimal. So 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5
Okay.
of this MSP. So that's the value that we are reading. So these correspond to temperature values. Okay. So using that, we are actually negating the temperature if it is negative. That's what this is. So I don't think we'll be able to produce negative temperature without a fridge. So that's it. You find this
And
interesting?
as you are using this Seed Studio also, right?
Yeah.
I
So
think you
I
have.
for this I am not using Seed Studio. I am actually implementing the whole thing with Wire.
Okay. Is there any difference using multiple microcontrollers? Like we are normally you are using like Arduino or something, right?
Yeah.
So I have one more question related to ROS because I have
Is it a
learned a bit of.
one? Uh,
Sorry.
may
Uh,
I?
Yeah, sure.
Yeah. So actually, I was asking that switching to multiple microcontroller, is it having many differences, or we can just switch same code to multiple microcontrollers?
the same code will actually run in most of the thing because Arduino is a kind of very higher level framework. That code will
Yeah.
work, right?
Kind
But
of universal thing, right?
yeah, but the thing comes with the power that a board consumes, the speed that it can perform computations.
Uh-huh.
So now in the course that we are doing, we are just performing one application, right?
Right.
So there are multiple operations that you need to do, and an Arduino board maybe cannot handle most of the operations because it has lesser clock frequency and it consumes less power. But in the HTM board, it works in a higher clock frequency than the Arduino board, right? So it can perform more operations than that. If you
Okay.
want a
So,
performance intensive job that needs to be done, then you
right.
choose that way, right? And also the different peripherals. And if you see, now we are only using this Arduino thing, right? But
Right.
STM also have things like
ST.
timers
Okay. 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 Yeah.
and interrupt-based programming. You can actually accurately measure timings. So if you have a very uh, timing sensitive thing that needs to be done accurately, those things can be performed in an industrial grade board like ST board.
So,
While on the other hand, this Arduino is for simple projects like not
right.
performance intensive jobs, simple
Right.
things.
It's very the clock speed also very low.
Yeah. So,
So
so if
I
our
have one
board does only
doubt.
few things, it's
Mhm.
okay to do have a Arduino doing that.
Okay. So yeah, I was I'm having a one doubt. What is the board in industry they use?
Yeah, I think the ST boards are used mostly in the industries like for assuming you are having an application, an embedded system that is running in a factory. It needs to be processing data much faster rate than
But what I have noticed is
yeah.
the clock speed of ESP is much higher. Not much, but significantly higher than the ST boards, right?
But it cannot handle power intensive application. So that is also one thing.
Oh, okay. Yeah, that's
So
it
I
also.
saw that. I said that right. The operating power is also matter. How many peripherals that it can handle. ESP boards are used for IoT applications, which means it has some simple peripherals, but it communicate and process data at a higher speed to send it to a server or some things like that. It
Okay.
doesn't require more power for operating on that.
Yeah, it's
But
mostly
what?
work
Yeah,
3.3 volt.
yeah, yeah.
Yeah.
On the other hand, so in each manufacturers provide for a specific need mostly, and they also provide different spectrum of boards that can be used for different scenarios. ST also provides some boards that work in low power. So that depends on our application. We need to define what our application needs. Like we need this speed, we need this operating thing. We have tried this board, and this board can give this much thing. We have tested. Then you choose another board. This fails in this operation, so we are trying with another board. So that comes with that, right?
Oh,
Experimentation and stuff. So we have to define what our needs are, and we have to choose one. For beginners, you don't. probably you don't do much complicated stuff, right? You will just try simple programs. That's why Arduino is popular.
Yeah, right.
But with an SD board, you can do more, like with a higher level board, you can do more things that can be done. You can also have a image processing library that running there and add a camera to do that. So those things will be there, right? And the amount of program storage that a board offers, it is also there.
Yeah, right, right, right. I do not have very less storage capacity.
Yeah.
Yeah.
Since in an embedded system, we put the whole program inside the MCU,
Hmm.
the processor, it needs to be that's also one thing. So these were different physical parameters that is depend like that determines which board to choose for which application.
Yeah. Okay.
So
So yeah,
some
Kritika, you can also ask now. Yes.
Okay, so I was having a question. Like I've seen a lot of people telling about ROS because like some of my seniors used to say like Arduino and these stuffs are basic and you should learn ROS, right? So
ROS,
yeah,
can
ROS,
you spell it?
yes. ROS, Robotic Operating System.
Oh, ROS.
Yeah, ROS.
Okay, okay, this one.
So, so can you tell us the guideline how we can learn that?
Okay, I personally I have don't have any experience in this robotic operating system, but I have experiences in operating systems.
Okay.
So let me look to it just once and see what I can infer from it. Basically, okay. So this looks like I'm just saying what I'm seeing from this. Okay, this library seems to be uh, designed for building a robot. So this is so there is a free RTOS library that helps us easily deploy multiple tasks and run things, schedule the task easily. So here we saw a first program. We schedule the 4 tasks in a non-blocking way, but that has its own drawbacks because if what if some part of the task is taking more time in a loop, then the other things won't get the thing right. So there are schedulers which actually do this. And in a robotic process, there are multiple things happening, right? So that's what I'm saying. These are simple projects that we are doing. But in a robotic project, there will be multiple peripherals that are actually working together simultaneously to do this. And there, the process, like managing the processes, is there should be that should be done by in a very structured manner. That's what they're saying. So they have a set of libraries that you can build upon. So what uh, this bootcamp focused on is the basics, how anything is built in the embedded system, and we
Yes, sir.
chose C language and Arduino to demonstrate how everything is built on top of a particular framework. So this is one framework, right? Arduino, and there is STM Hall in which you can also write code. So so maybe let me try if I can do a STM all code uh, with this, and that will give you a sense of how other frameworks also look like, right? Actually, this support for Arduino in STM boards has an intermediate hall layer. Actually, what happens is when this Arduino for STM boards is working, this Arduino code is compiled to STM hall, and that in turn is converted to this one. So that's how this process goes. Each
Okay,
of
sir.
these Arduino libraries they have defined in STM hall, so that we can use that here. But if you want more control over which peripherals that you use, for example, uh, if we are using, so each library and framework has its own advantage. So we also saw there are different libraries for doing things, right? Pre-RTOS, so these are the different frameworks that we have. We have STMQ. That's where we use STM Hall to code. So that's specific for that particular thing. Pre-RTOS we can use in many things for building real-time applications. Real-time application sense multiple processes running in real time that you can easily develop with this particular framework. This framework actually don't have this setup and loop format, but a different format where you will create tasks and start them. So there will be, you will be setting up multiple tasks and they will be running parallelly. So that kind of framework will be there. The libraries, functions that will be defined, but everything boils down to here it is C. Not sure which language this is written. This might be probably written in C only. Uh,
Okay, sir. I
let's
got
check.
it. Uh,
Yeah, it comes with built-in functions for developing the robots and things that you usually do. That's what I get from this overview of this library. Okay. So there are many tools and frameworks out there for developing embedded programming, right? So I saw this MicroPython is there, Rust is there, and libraries built on top of those frameworks are there. So some manufacturers provide their own library to interact with the peripheral, right? So they need people to use their products. So they will also build libraries for them. That's why Adafruit is developing those libraries. And you can see the Seed Studio. Seed Studio is also a manufacturer, so they were developing that library for people to use this sensor easily, right?
yes, sir.
So it's like if you have ever learned any other programming languages, it's like for example, in a data scientist in Python, he first usually learns the basics of Python, then the libraries, NumPy, pandas, and how to operate on this. Right? You can also do the same thing by reinventing the wheel, reading the CSV file, and processing it, whole thing. But you already have libraries, so you will learn those functions that are already there in the libraries and use them. So this ROS looks like something like that. So it's kind of an industrial grade way that is already kind of quite stable, right? It's also a project that is developed and now it is looking quite stable.
Yes, sir.
Okay, their source code is maintained in double thing. Yeah. Okay. Any other?
Sir, one more question. Some months ago, I was working on ESP32 cam.
Okay.
Um, there, when I was uploading the code, it was like a hidden trial method.
Then
Sometimes, like,
okay.
yeah, it's not uploading properly. Sometimes, like, it's like if I try for 20 times, then it will upload for one time. Like, this thing happens, is just because, like, I have checked many hardware devices back then, but it was working for only one. और ऐसा कुछ हो रहा था कि कभी हो रहा था चल रहा था फिर कभी नहीं हो रहा था तो ऐसा क्या हार्डवेयर में सिर्फ ESP32 के आम के साथ ही प्रॉब्लम है या फिर और भी ऐसे ESPs
So
हैं
have
जिसके
you
साथ ये
tried
प्रॉब्लम
different
होती है
ESP boards or you just tried one ESP board? It might be the problem with the board that you had, maybe the loose connection in the pins of the board that was causing that issue. Have you checked that?
यस सर आई हैव चेक दैट इट वाज करेक्टली मतलब बिल्कुल सही था सारे कनेक्शन सही थे इवन
Oh,
व्हेन आई
it
वाज
might be the
ट्राइंग अगेन
internal damages in that board, right?
ओ
Everything is a
ओके
physical component. So
अच्छा
these things
जी
happen when you actually do things with the things. So today, when I demonstrated with an actual board, you see that loose connections can happen, right?
जी सर
Yeah. So that's what. So once actually, I was developing a like in my college time, I was developing a remote controlled car as for a competition, and we were trying to uh, run it. Everything is perfect, and we said like we saw that it's moving slowly, very slowly, and then we added two more batteries to increase the power that it had,
हम्म हम्म
and it was still not working. And after like half a day of uh, wrecking our brains, we
हम्म
found that the battery holder was faulty and it was loosely
ओ
connected. The
Oh,
battery.
oh, okay.
Then we actually tied the battery holder with a thread to tighten it. Then it was running as fast as it can.
Okay.
So
So
this, yeah,
this happened with me with jumper wires.
yeah. This would happen when you are working with real hardware, the loose connection. So, what checking the connections is the first thing that you need to do when you are working with the real hardware. In simulations, everything works perfectly, but in real world, it's not as cool as that. It's
Yes,
And
doable.
sir.
Professor Johnny Garman once said that if your circuit was not working in first attempt, I think you are in the right path. So yeah.
Exactly.
Actually, I have one more doubt.
Yeah,
So, can we directly use microprocessors as microcontrollers?
you need to build a circuit on top of that. You need
Because
to give.
I want to minimize the size of a robot or something. Okay.
Yeah, I'm telling that. So there are different boards that use the same microprocessors are there. With the same microprocessor in unit, like the same thing, the same microprocessor, there are different boards for different purposes from the same manufacturers are there. So if you want to minimize the power, first let's see whether that particular microprocessor, that power consuming thing is already available. And there are like for example, the ST microprocessors are actually used by other people, like other manufacturers. To they build a board on top of that. So if you see these boards, I think some of the boards are there. See this ST boards. Let's see that. So there are this generic boards are also there. Some this generic boards means they are just for this generic specify this generic microprocessor, and there are different boards that will actually use this microprocessor for that. You have to build a circuit on top of that. The power, the circuits for the GPIO, all those things you have to build, and some manufacturer also provide that thing. So if you want to design your own PCB, you can do.
So the programming part can be done same as the microcontroller,
Yeah,
like Arduino or
yeah,
something.
yeah, yeah. The processor code is same,
Mhm.
right? So the for example, the ST, if you take any ST microprocessor, that processor has certain number of registers, and that registers only determine how it works. The internal timers that it has, all those things are within it. Correct.
Okay.
You can build
Right.
a circuit on top of that, like whatever you want, and use those pins as you need.
Right. So actually, what my interest is to minimize the size of the board. So the
So
basic thing that is required to build a board is, I think, first is power, right?
yeah,
And second, we have to program. So we can program
so
it.
I actually showed in the first day. I think there are the how do you can build
Yeah,
a
you have
Uno.
shown the
Yeah, yeah,
Arduino thing, right?
yeah.
It's something like
So
connecting
Arduino is
some.
a simple IC that
Yeah,
you
yeah,
can
yeah.
easily put in a breadboard, but this processors you cannot easily put in a breadboard, right? You need a actually manufactured PCB to do this
Okay.
these things. So Arduino, that's
Because
why people who want to
as
try out
per,
different things prefer Arduino.
yeah, you can just took out the
Yeah,
processor that used in this
yeah, but
Arduino.
these you
But
cannot remove from
we
here.
have to de-shoulder this thing,
Yeah.
right?
And you cannot also put this in a breadboard for right.
Yeah, right, right, right.
So that's it.
Okay. So I think the smallest microcontroller is this Seed Studio only, right?
Smallest microcontroller. Like, which one? Or which
Is
one?
it Arduino Nano?
No, no, I don't think
So
so.
there are different like for example, STM also provide small chips. For example, I think there is something called as blue pill. It's a small thing. See this one.
Uh, okay,
It's a minimum system development board.
Oh,
STM also
uh,
provide boards like this,
okay.
and Arduino also have this nano
Arduino,
board.
I think Arduino Nano or something like
Yeah,
that.
that is there.
Arduino.
Arduino also have different versions of Nano with some Bluetooth support or something like that for
Right.
specific IoT systems.
Right.
This has very minimal things, some analog things you can see here, and some
Uh, but in
digital
I
things.
think what's that? As sorry, Seed Studio board, we have Bluetooth and Wi-Fi inbuilt, and the
Yeah.
size is I think smaller than this STM32F103.
So you have to do a bit of research to do that, right?
Uh-huh.
Like said, ESP also have this thing. Uh, search
Okay,
for
yeah.
the.
I search for that
You see
actually.
this
Yeah,
one, this
that
one you
that
are saying.
yeah, yeah. Seed Studio.
This is actually ESP board. Like they are built on top of. Seed
Right,
Studio
right,
is a manufacturer.
right,
They built their board on top of the ESP microprocessor.
right. This is the ESP board only.
Yeah,
And one more thing, I just
they are using this board ESP, the C3 Tiny.
yeah. And one more thing, I have just noticed that I have one ESP Node MCU module.
Yeah,
So they just used a simple this ESP chip and
yeah,
just build a circuit around that. So if we can use that chip directly, I think we can do that.
yeah. You can use the chip directly if you have a circuit, right?
Yeah, because it have pre-built some circuit.
Yeah.
Have some circuits.
Which one? The Node MCU.
Yeah, the Node MCU 8226, if I'm not wrong.
Yeah, the Node MCU will have that. Yeah,
Yeah, uh,
this
it
one.
have two parts actually. Yeah, this one only.
Yeah. So, what are you saying? Like,
In that, I actually have noticed that the circuit that Wi-Fi module is there, right?
yeah,
So it's actually removable. We can desolder this thing, and we can use this thing separately. So there is not requirement of this whole board, right? Because we can program directly with that. We don't need anything else.
so what you're saying is you just pick out this
Uh,
module.
Actually, it have a small chip. Let me show it once.
Yeah, yeah, it has a small chip. You can program without the board. But why the development board is there is you want to
Yeah.
connect peripherals to it, right?
So we can connect peripherals to it also directly.
Okay, using this one,
A
red board.
simple shoulder wire also we
Okay,
can
you can solder
have.
the.
But what is the purpose of using the whole board actually? I just want to know. To
These
enhance
are
the.
development boards.
Okay.
These are development boards. You see, like prototyping boards. What does that mean? You don't want to solder things.
Oh, we can just plug and play. It's like that.
Yeah, the whole purpose of these things. These are prototyping boards.
Okay.
This is not like you. This if you want to try out different things, that's why these boards are
Okay.
for.
Okay.
Okay.
Um, Sir,
Yeah.
last question. I have a general question from a student who is not able to join because she is out.
Okay.
It's a general question, not based on this boot camp. She was asking, like, as a data scientist, I have interest in robotics as well. How can I pursue robotics and as well as data scientist, like combining the field?
Data science is a kind of a global field that you can. A data scientist can be anywhere nowadays. Like everything that has data associated. And robotics, in automated robotics, data science and data processing as like it's combined together. For example, uh, in IoT applications, in most of the IoT applications, data is transferred from one place to another, and those are logged, and like it becomes the logs are growing as the device keeps running. For example, there is a fridge that you have, right? And like not talking in the context of robotics, it's kind of somewhat linked to IoT because that's where most of the data processing happens. But there is also data processing that happens in the field of robotics. But most of the things happen, like the data science is more suitable to is IoT, where devices communicate with each other and the data, more data that the device generates. For example, a fridge generates data on the temperature, things that data can be processed by a server, like not in the processor maybe, that is the design choice actually. Whether you process the data on the processor or in the server is the design choice based on your application specifications. And you process the data. For example, there is some unusual activity in the fridge. Maybe the temperature is changing, fluctuating in a frequent manner. Then there might be some problem with your compressor or something, right? So how do we process this data? There will be just readings coming from the value, right? All these readings
Yes,
are.
sir.
So this is kind of a time series data that is generated, and you process that data like with some algorithms to say that there is a period of time where this mean of this temperature is fluctuating very frequently. Those are things can be analyzed by a data scientist, right? Yes, they know how to handle data. In IoT context, it is more thing, but also in robotics, in some cases, it's more of an AI ML thing in case of robotics rather than data processing thing. Like for you use machine learning algorithms or this especially this reinforcement learning algorithms nowadays to uh, make the robo stabilize in the standing position, do some actions in a stabilized way, reading the sensor values. So that's a very kind of advanced thing that you learn in RL. So that is reinforcement learning. That's a separate field out there.
Okay. So you meant like if we go in data science, it is mostly used like the application is in IoT, and
Yeah.
if we go in robotics, AI and ML is mostly used there.
Yeah, it won't be like a data processing or a data scientist kind of job. It would be a ML engineer or a ML researcher kind of task in a robotic field. But both
Okay.
involves data. But in how you deal with it is in the robotics you use very advanced algorithms to do that. But in IoT case you use very simple data processing things, simple statistics kind of things to infer things about that.
Okay.
That's it.
Sir, one more thing, like suppose robotics is, I guess it's so huge, is it? So it has a lot of branches combined in robotics. Uh, if we want to choose one, like only AI, ML engineer or data science, can we do so, or we should have some basic knowledge of electronics and electrical components, like
You
components of
like
like
okay, okay. Let me tell you.
yeah.
All these ML engineers and these things lies within the system, just like our simulation. If you want an actual robot to run on the ground, you actually need to know things like the mechanical and electronical things of a robot, because that's the actual thing. It's just like that thing. So if you're just focusing on A and ML, you will be just in a simulator, not in the real world.
Okay. Yeah.
Okay.
Yes, sir. Got it.
Yeah.
Yeah, so
Okay.
actually, I have one doubt. Actually, not a doubt. Actually, a general query. Actually,
Yeah.
so what is the scope that we can expect in IoT or robotics after this microcontroller coding thing?
Sorry, after this.
After learning this microcontroller coding or this whatever you can say,
Yeah.
yeah,
Like, can you repeat it?
the scope in market or in industry after
There is
learning the
there is
microcontroller coding.
there is a lot of scope in industry actually for microcontroller coding, because most of the devices that you see today are like, even in a lift they have microcontrollers handling how the lift processes.
Okay,
Those are actually invisible within, like, most of the devices nowadays have this IoT enabled things and microcontrollers gathering data. For example, industries like handling with uh, chemicals, production, those kind of things, they use most of these embedded devices to monitor or control the things.
right,
Like, for example, I was in there is a production line and there is a embedded system that actually has some sensors and checking the quality of thing, or there would be as a like assume there is a chemical plant, you want to monitor the temperature, and there would be a system that is embedded there, right?
right.
So those kind of things will be there in every place in these kind of industries. Nowadays, you might have heard this term called Industry 4.0, where everything is automated and IoT enabled, like all the industry things, the robots, the machines are connected to each other. They share data between each other. So these applications are actually huge. But the thing is, you have to be a pro if you want
Right.
to explore. So you have to learn things. You have to do projects. That you have to develop your knowledge on different actual thing by actually working out on projects. So that's what it is.
Yeah, correct, sir.
Yes. Yes, sir. Okay. So anyone is having any other question? I guess no. So as we have come to end of this boot camp, I want to thank each of you being part of this journey, and special thanks to Sir. To Oh, you have a question?
Jagannath,
Uh,
I think, okay. No.
okay. So and so let's take some time to relax and enjoy Diwali festives with your family and friends. Wishing everyone a joyful and safe celebration. Happy Diwali, and don't forget to stay tuned for our upcoming events at Yantra Robotics Club. Let's make this last session a great one. So, thank you so much, sir, for joining and teaching us a lot of things.
Yeah.
Thank you
So
so much.
thank you guys
Yeah,
for organizing this.
thank you so much, Levin sir, to just make this session happen. And at a very short duration of time, you just accept our proposal. Thank you so much.
Yeah.
Thank you, sir.
Thank you.
I would like to thank from the Saran House.
I think that's all, right, guys.
Yeah, thank you for your time. Actually, sir. For 3 days, you just continuously teaching us.
Oh.